I'm pleased and honored to be here doing a session now 1 hour with you. Hopefully, you can keep the balance. I hope you had a pleasant breakfast and some energy on the coffee. My name is Uli Waltinger. Worked with Siemens since 14 years actually. Makes me still a greenhorn actually in the Siemens ecosystem and the Siemens organization. 10 years of that I was working with corporate research, leading the machine learning research in the corporate world, and then since 4 years also working for Siemens Advanta in shaping a bit of the industrial AI agenda for external but also for the internal factories and partners. I'm looking forward to share a bit of the insights, our perspective on actually industrial AI, specifically on a bit of the manufacturing and production environment and what's the definition out there. 4 different topics we would like to, around 40 minutes, maybe 45 minutes. I'm usually speed up talking, so raise your hand if you're, I'm too fast or too unlistenable to there. We want to talk a bit about the difference shortly about industrial AI, what's the working definition, let's say, on industrial AI, and how we embrace it at Siemens in our use cases. Second aspects, I want to dive a bit more closer in terms of what are use cases, what are typical use cases, what are rising use cases that typically match to somehow the expectation, but also to the value generation on shop floor and top floor aspects. Third one is one of the pivotal aspects. Industrial AI is everywhere currently, the buzzwords is somewhere, but how to get scale? What are certain kinds of best practices that we have in terms of scaling AI technology on shop floor and in production environments? And last but not least, short setup on a bit of what's on the horizon, hashtag agentic eats the world all along the line. So, and feel free to jump in and raise questions for sure. And you can take photos or videos, right? Everything, I'm more than happy. Connect also with the squads to the slides, stuff like that. Connect with me in LinkedIn. Happy to share, more materials and these materials as well, right? So AI and Gen AI, if you run around here, right, bit of a small intro, is obviously eating somehow the world. November 22 was the momentum where, all executive, reached out also to us and said like, what are we doing with ChatGPT, right? And since then, since the last 2-3 years, Gen AI has somehow multiplied along the line, also in the corporate world. If you look now, co-pilots, industrial co-pilots, and these kinds of applications are, streamlining almost everywhere, right? And the expectation, right, on consulting, is enormous, right? 25 billion interactions, 100% of the workforce will be impacted by 50%. Well, what does that actually mean? So, but it's significance, right? And then there's also a high expectation on unleashing Gen AI for the internal productivity actually at scale. Whether this is now 60 or 70, whether it's 40 or 30, it actually doesn't matter that much. It's significance. It's significance what makes here. At the technical basis, what significance is the benchmarks. Obviously, AI algorithms over the last years, has significantly, at scale, actually, improved on various tasks. Previously, 8-10 years, we measured the performance of these kinds of algorithms and machine learning methods based on accuracy, precision, recall, these kinds of statistical measures. Nowadays, we measure these kinds of capabilities in human tasks, reasoning, comprehension, listening, calculation. So basically, that the machine learning systems and data-driven system has evolved at a superhuman performance at selected task, and somehow still fragile, but still astonishing, right? And if you depict now, not only the year of 23, 24, or 25, let's give it another 6 months. Let's give it another 9 months. Maybe let's give it another 1.5 years, right? You can imagine how the benchmarks actually moving further, and this fuels the hype. So this is here to stay, right? And this is at a speed that is untangible and somehow still tangible very well in all our organizations. Obviously, when you look then on, Gen AI, OpenAI, this is Sora, then you see, somehow AI went into a bit more, let's say, democratized way. Everybody can now generate these high-scale, right, video sequences. Sora, the prompt is, a stylish woman walks down a Tokyo street filled with warm, glowing neon and animated city signs. She wears a black leather jacket. So you're scripting, you're describing what the output should be as an input, and it turns out in the very photorealistic environment as a video sequence, right? And then you say like, yeah, Lee, what the fuck? Why are you talking here? We're talking industry, we're talking manufacturing, we're not talking consumer tech, right? It's very interesting because it bears some kinds of physics information. We at Siemens are very proud in having domain know-how about physics, about simulation, about representing the world in the real world, right? And it turns out that these systems and these engines have somehow under the hood, into the engine, quite some physics somehow understanding, let's call it understanding, or let's say representation. The reflection in the mirror, the drawing of things, these are normally modeled in physics environments, right? And nowadays you can somehow bear that these kinds of statisticals on steroids, right, have some kinds of representation of domain know-how, which is for us quite interesting, right? And obviously it's clear that, you know, from generating a woman in a Tokyo street, you know, with some nice physics-informed, let's say, aspects, to the world of where we are living in like a metaverse or a 3D environment, in software environment, in immersive aspects, in real-time rendering, in terms of, you know, dealing with the complexity, is a game changer in these kinds of aspects. We still need to untain that, but it's a game changer. It turns out showing a lot of data and a lot of compute on these models can exhibit with good learning strategies, quite some physics-informed information in there. And that's a very interesting aspect. A second interesting aspect is obviously the energy compute, right? We at Siemens do energy data center, right? We support the customers, Google's, the Metas, you know, and so on, in terms of shaping the energy demand, right? And also to optimize the energy demand. So one key application also for us is now, as the energy demand, you know, will grow significantly. We're talking about 6% of total energy demand will be expected, right, in 2060. That's like almost next year, right? Is on ICT and is on data center. And so we need to apply industrial AI application into terms of cooling, better energy usage in these data center, because I think it goes up. To give a bit of example, the rendering which I did for a storage company, right? The one frame of this image cost one time charging your iPhone. One frame. You saw the video prior, right? So, and now you see the entire world. So the energy demand is significantly increasing. While the more we eat, the more, you know, more capabilities we shape, and the more capability we actually inject in our application, obviously, the higher the energy demand will be significantly. Nevertheless, right, obviously, we are touching the real world, right? And I think this is a super cool, actually, it's a real advertising, no Gen AI, right? In this case, it's for a Belgian company. We said like, hey, yeah, for sure, right? ChatGPT, right? Finish up the building. So when we, you know, our purpose is a bit of, you know, we touch the real in the digital world, and the real world is something very tangible, very practical, very, you know, manufacturing, very down to the earth, certain kinds of aspects. And in bridging these kinds of environments, right, it's always a bit of a challenge, right? But nevertheless, we need to accept nowadays that beside us, there's an AI involved. There is an AI as a companion, as a co-pilot, as an assistant in there. And to be frankly fair, also, the AI need to accept that there's a human involved in bridging these kinds of worlds. And going further, I think it's important to say, like, both need to be, you know, very empathic that both worlds exist and both need to collaborate and cooperate. And that's why I think the age of industrial, you know, augmentation, let's say, AI-based augmentation, we need to accept that this is the new world, also in digital aspects. If we now streamline a bit more closer on that, then, you know, you have the typical application in industrial AI. It goes now all across the verticals, right? If you go to the Siemens Boozy 9, right, all in about pharma currently, but if you go here to Accenture, whether you go to Microsoft, it's industrial AI is everywhere, applied to pharma, to food and bath, to water, to cooling, right? And the typical application, if you look then down to the earth, it are still, you know, quality inspection, camera systems, you know, on top of that. It's anomaly detection, it's process optimization, right? It's a bit more autonomy shipping there. So the aspects and the use cases along the line are still quite tangible, and it gives us a good operating model there. And obviously we don't only do this because of, you know, we want to do anomaly detection or we want to do predictive maintenance. Obviously we have the key business drivers in order to fulfill that. And that means, you know, increase efficiency, reduce the downtimes, improve the quality, minimize production, lower inspection costs or the energy costs. Energy comes to things, I will pick up on that. And maybe as a small pulse check, I don't know if you know Menti, because it's hard to discuss in here. I would ask you to scan or join menti.com maybe with your mobile phone for a second. Don't go to Flappy Bird, don't go to app gaming now, please. Don't check your emails, but go to Menti and give a bit of pulse check on where are you currently. So usually while you're typing, I appreciate that you do a bit of the feedback and give me a pulse check on that as well. So usually when we come to partners, also in the Siemens business, individual Siemens business. Siemens is a large company, right? Almost 300,000 people. We have various different business units, from process automation, factory automation, energy. We have the Friends of Healthineers, so we have quite a lot of applications and factories to consider, right? And usually we assess these kinds of aspects along this, along the 5 categories where we say, like, hey, what is the current level of readiness in there? And maybe you can swap down there. So right, that's a good curve. So beginner level, that means we are just starting to explore. We still see quite a bit. A majority, what we see also in Siemens, is something between 2 and 3. That means, we have identified certain kinds of use cases. And get started. We tried it maybe with a working student. We maybe tried it with a partner, with a consultancy or an external IT provider, right? 3 is a bit more, it's foundation line. We're starting to roll out, maybe on a single line, on a production line, and maybe even sharing best practices. 4 is then already, okay, we come in more mature behavior and say, like, there's a center of competence maybe there, or there's a central department, there's a program associated it. We have an understanding of MLOps and like in operations in these kinds of aspects. And E is like this transformative, right? That means it's part of the DNA. I was most recently last week actually discussing and joining on an investor conference, and these companies who invest in scale-up companies, they decided that they are only now investing in startups founded after 2022. Because they say, like, they are GenAI by nature and also shape their process like that. That's a kind of saying, I'm still spoiled whether they play it that hard, to be frankly fair, but I thought it's quite nice. So there is certain kinds of companies which are part of AI first mindset, data first mindset, and build then not only the business models, but also the internal processes around it. And that's kind of an interesting aspect. Thanks so much. Can you swap there back? We'll refer to that in a second. So if we talk now a bit of an industrial AI, more specific, then from Siemens' perspective, we have 2 sides, I guess, right? On the one side, it's industrial AI, means for us, it's scalable, it's robust, it's secure, and it's trustworthiness. On the other side, we have from the application a trend, sometimes the colleagues call it dark factory aspects, or let's say shifting up the autonomy. Dark factory is a bit of a saying where, the factory can be actually lights out factory, right? These kinds of aspects. So you want to move certain kinds of part of your production and manufacturing on a level that the autonomy takes most of the aspects in there, and you have certain kinds of human augmentation for critical tasks where it's not possible, still not possible, or maybe didn't want it to have it in there, right? So these kinds of are the key driver. For us, we see 3 applications areas, along the line of the industrial grade, which is called on the one side robustness, the second side democratized, and the third one with a purpose. And this is where we see AI and industrial AI, specifically industrial grade AI, right? Robust means in having this specific aspects covered, like secure, robust, explainable. If you're deploying AI on shop floor, there's a human involved which asks why. If you want to shut down a line or give a recommendation to increase the speed of the conveyor belt or to decrease certain kinds of parameters, they will ask, based on their gut feeling, based on their plethora of years in experience, will ask you why. Why are you doing? Why should I do it? What is the best? Are you sure that this works? Are you sure that this maybe has an impact on capital aspects? And that's why these kinds of explainability and this industrial grade robustness is quite a key theme, which in manufacturing is an important aspect. If you have in Google or in your Amazon or in a shopping basket, some ranking got wrong and you get sneakers instead of a t-shirt, right? Nobody cares, to be frankly fair, because you have still this human supervision. In a manufacturing department where it's time critical, these kinds of quality aspects matter significantly. The second one is about democratized. If you go in shop floor and manufacturing aspects, the actual chief data officer and chief innovation officer are the process engineers. They are driving the value generation in production lines. They are knowing about the lines, about the quality, about the parameters to tune, whether to increase or whether to decrease, right? In order to keep the quality stable and still, make the throughput. So how do you enable this kinds of enormous competences and experience with digital technology around AI? And this is where democratization of AI is a vital aspect. That means you want to equip them with the tools and say like, we make you even more stronger, right? We make you even more competent and more faster. And we'll take you on the journey with us, right? In terms of, in terms of embracing more digital technology for the business value. And the third one is actually, obviously, we are in an environment which are challenged by a lot of challenges, actually, not only in our factory or in our production, but also around it. It means on the energy, on the water consumption, on the global trends that we have. So we said like, it has to fulfill also a purpose, right? In terms of a meaningful representation and contributes to sustainability aspects. So I'll give you a good example, right? One of the good examples is, let's say, autonomous robotic picking, right? This is an example where we do have certain kinds of tripping, and normally you would do then a bit of a fixed rotation. How do you package certain kinds of parts out of your basket? In this case, AI learns from synthetic data and means like you get a cut model of the actual pieces. The pieces lie in this little case aspects, and the robot needs to, based on vision, needs to automatically detect what's the best part in picking that, and then having a more flexible, adaptive robotic picking, right? And we need to trust that these kinds of adaptability in terms of the parts are always different. They're shuffled. They're different color. They're in a bit of more complex environment. So we need to make sure that this kinds of robustness is there and the adaptability is with these kinds of systems. Second aspect is then goes further. Once you mature with more aspects, like I'm not only having one robot system that does stuff and maybe has certain kinds of cloud and edge connectivity, you're starting then about what we call the MLOps lifecycle, which is a tricky beast, to be frankly fair, because for the first time then mostly in organization, IT and OT converges together. If you ask an OT on a factory shop floor and say like whether they want to have the IT department push down information to control something on the shop floor, they will say like, nah, we don't do that, right? We don't do that, right? We rather pull it, right? So OT calls to IT and says like, yeah, we'll tell you what to do. So an ML ops, specifically from cloud to edge, is something where we have this transition, where suddenly OT people and competence and experts need to talk to IT experts and say like, how do we make this digital work actually? How do we train our models on cloud? And how do we deploy it actually on edge? And how do we make sure that the robustness, the secure, the trustworthiness is still equipped, even though we have certain kinds of aspects like model drift, data drift, so that means impacting real world data on your model which has been trained aspects. Therefore it's important to have like, industrial grade MLOps pipelines, which is more than just a cloud SageMaker environment, to be frankly fair, just to pick one. The second parameter is democratized. I said like one typical example, and if you go along the line here, all the aspects is a bit of the, let's say, vision eats it all, right? If you don't have deployed in your manufacturing department some kind of vision, you do it, right? Everything a human can depict in 1 second, a computer system makes it even better, most likely. But the more important aspect is not the technical capability, whether we can do low code, no code, whether we can identify these kinds of corrosions or split detection or packaging sizes or counting certain kinds of product pieces. The question is, how do we ship this capability on a process side? So the process engineers, again, right, our chief innovation agents, right, in the factory shop floor, how do we equip them with the tool stack so they can train these systems? They can adjust it in their configuration, in their actually task. Because here is maybe stuck chips and detecting whether we need to slow down the conveyor belt, and here maybe the packaging, right? And say like we are running a bit of over packaged in these kinds of aspects. So therefore, bringing no-code, low-code capabilities or abstracting, let's say, the machine learning models on a user experience that is understandable, adjustable, and configurable by process engineer is of vital importance. Therefore, democratization of AI in terms of making it more accessible and customizable by the customer itself, by the partners, by the process engineer, is essential going in the value generation. The same goes actually for the copilots, the suite. Whether we're talking here, this is an industrial copilot today, actually launched on hydrogen production aspects. It's complicated things somehow, and with this, obviously, one can leverage, about the capabilities of GenAI in terms of how do you access the documentation, how do you access the best practices, how to configure it, right? How do you ship the knowledge that is actually accessible? Not only but by a single process engineer and by a single repository of best practices or documentation of the individual parts, how do you ship that to the process engineer in designing aspects? And I think the capability of natural language processing in terms of synthesizing, summarizing, guiding, interacting along the copilots or chatbots and other likes, right, is quite significant in coming very detailed. What do you need? What do you trust? And guiding the process engineer, which abstracts again from the technology. They don't need to know about transformers, about OpenAIs maybe, or about Mistrals, about the GenAI tech stack, but they say like, give me the information and guide me through this process. How do I set up? How do I install? How do I have this AI and human augmented implication? And that pays also in the bucket of democratization. Last but not least, it's purpose, obviously. And this is, I think, which makes me very proud on Siemens, because we are an infrastructure company. We are somehow on the transformation to a software company, right? But we're infrastructure. So I'm talking to grids, I'm talking health, I'm talking water, I'm talking, throughput. I'm talking about environmental monitoring, these kinds of aspects. And that makes for us, to be frankly fair, quite easy to say like, okay, and this is one example, leak detection in terms of, it's actually in UK, there's, a bottle of water. We similar have these kinds of aspects in gas. We have the similar kinds in oils, and also, older, let's say, energy transition, where it's a lot of waste is actually, produced. And AI and sensory information in combination helps very easily to identify these kinds of typical applications, right, which directly have a good business case. Energy still okay? You can hear me okay? Okay, all right, good. So let's come to the second part. So we learned about now industrial AI. We learned about the three main aspects. So it should be industrial grade. That means it's robust, explainable, trustworthy, somehow caveats in there. We learned about the importance of democratization, so it needs to be applied not by the experts, but applied by the process engineers and by the fellow who are actually working in the individual lines or in the individual businesses. And third one, it should have, and at best it serve a purpose, which is a business purpose, yes, value creation, but hopefully also changing the world to a better place. So what are typical use cases? If you start with use cases, and if you go to a factory or to a partner, right? Most if you go to a plant owner, they say like, yeah, let's talk about my production, right? And talking about production means like, let's talk about my productivity, right? And if you talk to them, it's like, what do you mean with productivity? Then you come up, maybe you could come up with such a framework. Say, okay, let's talk about your equipment. Let's talk about your process. Let's talk about your materials. Let's talk about your energy, and let's talk about your labor, right? These are a bit of the typical aspects how we get started. And then we can say, like, what is the downtime maybe from equipment level, right? What failures do you have? What is the speed losses, right? Which equipments, are underperforming? How do we tackle it on OEE, basically, and overall equipment efficiency, right? Then the second is a bit of, what is factors for the quality aspects on the process level, right? Sometimes, to be frankly fair, we come in there and say like, hey, let the AI do the magic in terms of, and then you look at the factory shop floor and people running not very coordinated, let's say, around, and then sometimes it's not, let's say, AI or technology which helps lifting up certain kinds of OEE, but actually traditional factory planning, why is this machine here and not here, or why is this supporting equipment not here and there, right? But in principle, obviously then with data-driven aspects, you can slice it down and measure it. And this is very important. So go in there and get the golden shoes and how is the material? What kind of a failure? What kind of breakdowns? What kind of, get the size in numbers, right? The same goes then to the material related. Material related is something which specifically in manufacturing, waste and energy costs makes it always a good business case, to be frankly fair. Going in there and say like, what's your waste rate? What's on the production line, right? What's the energy rate, right? What if it's 10% down? How do we uplift 2%, 3% OEE points, right? In order to have both, on the one side, seeing the business benefit, but also having a glimpse on how to solve it or approach it, right? Energy-related cost becomes a thing. Energy goes up, cost goes up. It becomes a business case. Was back in the days not, even though everybody is somehow equipped, but it becomes a good business case. Still, it needs to still satisfy the traditional use cases that you have. That means you still need to calculate the ROI and you make it, invest versus a return going further. And then, not but not least, it's somehow in many companies, it's a transformation of the organization. That means labor, and it means also train-the-trainer concept. It's actually part of a digitalization program. So therefore, on the one side you have a stakeholder, which is the production, maybe the factory lead, right, which goes there and say like, I have these typical waste and energy problems. On the other side, you want to equip yourself in the headquarter-ish or in the corporate aspects, because it's also a transformation of the people in terms of upskilling, training, competence building, getting the transformation done in terms of more leveraging more tech spec in there. So let's look a bit on typical use cases, right? So we made together with Reuters a survey, right? What are the 300 companies expecting to be there, right? And happy also to share the report, right? It's free, you can download, ping me on LinkedIn, I'll share the entire data on these kinds of aspects as well. So what we can see is obviously that in the darker green is a bit of currently applications that the companies are implemented. The lighter green is in 3 years, and the light green is a bit more in the future along the line, right? One can see application implemented. A lot of things goes down to what's called real-time operational decision making. Let's say process parameter controls, these kinds of aspects. Hey, here's my process, this is my output, this is my OEE, this is the energy bill, this is the breakdowns, these are the aspects. I would suggest you scrim down, you increase here, you throughput there, and these kinds of operationals. Feels very dashboardy. It's a lot of aspects goes into mobile first, iPads or let's say wearable devices in there. Then supporting the process engineer, not only in a one-to-one, like one engineer for one machine, but a one-to-N. That means one person to a set of machines to be guided and advising. And I think this kind of is a mixture between, on the one side, digital enablement, shop floor management system, let's say, and on the other side, data-driven insights in terms of recommending, hey, set up the set point higher because I think you will run in terms of, stock chips or in terms of certain kinds of process environments. Energy management is something which everybody somehow, at least on the dashboard, implemented, and then first kinds of recommendation building, what should I do in order to reduce certain kinds of life cycles. This is a thing, and predictive maintenance, obviously, is something which in practice feels still outlier detection in many cases. To be frankly fair, there's a couple of cool applications in there, but in daily life, it's still more complicated, to be frankly fair, and anomaly detection, outlier detection still feels in many applications as the right thing, and I think a lot of put it in this bucket, to be frankly fair. Uprising sustainability impact assessment sounds weird, but there's a trend with the corporates now putting the agenda of sustainability reporting and supplier reporting in there. Now factory leads are challenged, like how do we make this? What does it mean actually for my factory? How do I report back also on aspects, and how to make a positive business case is the most assigning trend in there. And that means also with regards to shaping that, so what is the uprising use cases in there? That means energy analytics and energy management becomes going further, the most trended use case companies expect to have implemented and will be implemented. It's kind of interesting, obviously, but it's not surprising given the fact. Going further, what are use cases? I think currently enhanced product testing and simulation is something which you can see everywhere. What moved back in days in terms of leveraging more data, in terms of building predictors, building classifiers, goes now in terms of building simulations. So how do we ship more aspects of our production in a virtual environment which can simulate certain kinds of aspects? The previous years were mostly in simulation dominated in terms of factory planning or virtual commissioning, these kinds of aspects. So before we produce or resample a certain kinds of line, now is the moment that factory leads look on the aspects. Okay, here is my as-is line and my conditions. Let's build of part of the machines a simulation around it and say like, are we actually leveraging the most up there, or how do we adjust in the future going a product in order to be even better? And this is kinds of product testing and simulation becomes a really hard thing. And the same goes for product lifecycle management, thinking about more holistic. Previously if we run a process and it's like, okay, you have the, the dough making, then you have here the stocking, then you have here the, ingredients in the food and bath environments, and then you have here the packaging aspects, right? It was use case by use case by use case, and now you can see actually they're connected, right? Because if this is, then down the line in the upstream process does have an impact, and therefore it comes then closer on the one side on the entire product line, but suddenly also to the supplier before, and the outward feedback inbound logistics then as well. So this kinds of end-to-end, traceability and representatives are quite a hard case going further. Last but not least, I think uprising, what the data shows, at least on a small scale, the smaller use cases, let's say a single use case, everybody wants to have scale, right? But for certain kinds of aspects, it's not doable. And I think generative design for physical products, so how to design a physical product, is very specific. A lot of conversation we currently have, because everybody is tangled about the creativity of Gen AI and what can it do, what can it imagine, can it feed more process parameter, not only the specification that we have, can I feed it in the products, can I feed it in the documentation on that, can I feed it regulatory environments in there and come up with a new proposal of the product. So quite interesting, everybody is speaking, but very, very specific to an individual product, right? On the other side, waste and end of life becomes a thing, part of the sustainability trace that they have. So that means, how do we approach that? Usually, obviously, use case ideation, right? It steps with these three little fellas, right, along the line, which you may have seen from a plethora of from other consultancies or partners aspects. It still holds. I think you go to a factory, you say like, okay, let's spend 1 to 2 days with you, right? Here's a preset of typical other use cases others do. What does it do to you? What are your ideas? What are the one-offs? What are the scale-offs? Let's say use case. Then you depict it maybe in a week to join the value drivers in there and say like, okay, can we calculate certain kinds of rough business case, let's say, with it in terms of to see like where does it pay off and where does it pay in. Then you make an impact quantification, top line growth, bottom line improvement, risk, let's say. You have a bit of a matrix, right? Consulting kung fu, I call this, right? And then you have a bit of a prioritization list, which makes sense, where you say like, okay, this is I make and buy, maybe you license it or you buy it, and for certain kinds of key critical aspects, maybe you implement it by yourselves, right? But this is a typical aspect everyone should do. I think it's nowadays a matter of, a couple of days to a couple of weeks, depending on the complexity of organization. If you don't have it, do it, right? Happy to spawn more material as well on that. All right, third point, 25 minutes to go. We'll want to leave a couple of minutes, obviously, left for Q&A as well. So how to scale industrial AI? That's a bit of the main question. Again, love data, right? And therefore, the data comes again. So based on the survey we did, it's like, you know, if you say like, we asked about the question, are you able to scale, and what does the scale mean in terms of business quantification? And the rough run numbers, you know, along the line was about 35% more valuation in there. So that means 2 times the success rate and 3 times the return if you are somehow prepped in scaling AI. If you're not using and applying it, for instance, in a single line, on a single packaging machine, or in a single molding machine, or whatever you're talking, but you apply it to, you know, you can copycat basically, right, into other machines and build blueprints in terms of for other factories or for your peers and the factory leads out there. So what's the challenge actually on AI, right? It's actually pretty easy, isn't it? That means you have a great use case, you identified it in a couple of days, right? So let's scale it. Why is blocking? Well, it seems interesting or easy. I just talked to my IT department, they will scale it, they will make it work. It's still quite challenging. So maybe you still have the Menti, please, you know, give us a bit of feedback to keep you energized, but also curious. So what is blocking on your side currently? What do you think is the bit of the blocking points on terms of scaling in AI in the shop floor? And I appreciate your feedback. I love data, right? So it gives me always a bit of bigger picture along the line of these talks. So it's appreciated. All right. So that's an interesting one. The usual suspects are data and organization readiness, I must admit. It's mostly not technology, even though I will show you in a second a different image, but it's mostly not technology, and that's very interesting. So the tech is there, right? It's not about, you know, reinventing the entire world. It's about actually how fast are you in accessing data. And we tried in Siemens quite a bit, I can tell you. Like 8 years ago, we did, for, I don't know, 10 years ago, the first data strategy, right? And we thought we tried it with regards to a willingness, an army of willingness. We know we are 300,000 people, a lot of factories, a lot of, you know, crowns, princes, and kings in there, right? And if you ask them, right, let's get one data lake together. Let's get the data representation together. Let's integrate all our factor. And they say like, yeah, sure, dude, right? This is still a challenge, right? It took us quite a bit, and in the end, somehow what helped us is we made it CEO attention. That means the army of willingness doesn't work. The forced willingness works top down. So if you're not anchoring data strategies, usually with most of the companies anchored on the IT side, the CIO, let's say, level. But if we have shifted it actually on a CEO level, Roland, and now pushing hard. He said like, okay, I'm the CDO, the Chief Data Officer now, in parallel, in order to push this down. Because data means transparency, and transparency not everyone wants to have. And therefore, you know, if you want to move towards industrial AI in your production, in your organization, you need to go the awful parts of, you know, pushing very, very hard in getting data being ready and accessible. And it's rather people side than a technology side. There's great technology around it in getting people out, you know, in connectivity and knowledge, in knowledge hubs, in knowledge graph, in populating that. It's again, not somehow a technology question, but rather in terms of a data accessibility, in terms of when can I see it in real time almost. And the other one is my organization ready to embark this kinds of data-driven organization as you want to have it? Business case, yes, business qualification. Maybe we can swap back, thanks. We again asked a bit of, and together with BTG actually numbers. Interesting if you speak then on an executive level, they come then also with regards to the trustworthiness again. And so like, yeah, we do have these kinds of in our production environment, but how do we cope with hallucination with an aspect we contribute to generative AI in terms of that we are not differentiating, is it a valid or somehow a bogus output, let's say, of these AI engines, right? The second is still skills, and as skills goes from shop floor to top floor in terms of knowledgeable about what technology, what the data, how do we cope with data standardization. And again, right, only 60% achieved the AI-related goals. I think the ambition level, if you call an executive level and say like, yeah, I want to have this double-digit productivity gain, I want to have this double-digit, right, energy and equipment efficiency gain, and still, have a hard time in materializing it. So what is stopping there? So 6 maybe certain kinds of things we see everywhere in terms of the POC. The foundation data capability I mentioned already, right? There's a big gap between actually business and manufacturing. These are 2 different castles, right? High IT, high business, and high production, right? Even so, the value generation is done on the shop floor, to be frank, right? It's done in the manufacturing, in the production environments, in the businesses there, right? Then lack of clear plan in terms of, so we got a POC, what now, right? So we have a prototype, what now? Then unrealistic expectation is something which you also see, like, okay, we tested it out, the working student showed it to me, so now we have a 20% increase of the efficiency, right? All right, go down, it's a Python notebook, it's not life cycle, this is not even tested on a significant way, these kinds of aspects. Missing operations on OT know-how, also IT talks suddenly OT needs to talk IT. There's a misalignment, and the misalignment also a bit of the funding. A €5 Python notebooks on whatsoever makes not a productive, scalable software solution that is continuously updating on the model side. So a couple of best practices at least, right? On the first one, right? Abundance of foundation capabilities. I think a notion, and you can use a bit of the hype, which is called data products. And I think a data product is a nice thing. Let's define data products as a data lifecycle. So that means you as a business unit maybe have a cool process or owner of a cool data aspects in terms of availability of a machine or the energy footprint of a machine. You can package this as a data product, expose it as an API, and others can subscribe it in order to integrate it in their processes. It sounds a bit weird, but it's actually a cool phenomenon. We are on our processes already. We have a data product platform, data cloud, basically what's called, where businesses can contribute as part of, let's say, a marketplace somehow, contribute their data lifecycles. And data lifecycles means you need to pay internally even, right, for that. I want to, subscribe to this data lifecycle because I'm interested in factory, factor energy usage, right? You can subscribe for that. The one who were very bullish, very beginning actually on data products is pharma. Pharma is an interesting aspect. Bits and pieces area, still silos in a lot of cases where I at least see, but in terms of in a single isolated castle, they are very bullish on data products. So if you are tackling in your factory in shop floor, think about a data product. That means maybe it's a business model even inside your organization to equip it and package it as a data lifecycle, you can see, right? Big gap between business and manufacturing. Make meetings, make trainer, make education, bring these modalities together. It's sometimes very easy, right? In terms of activities, these domains need to talk to each other. Make a forum, make a digitalization forum, make a best practice sharing. They need to share certain kinds of vocabulary together, and that's why I think it's very practical. Is bring the people together. They need to understand not only in a daily operation, but make it tangible in terms of tangible applications. Organization structure, right? What happens after deployment? So start, yes, with fail fast methodology. It's okay to start with a student, with an in-house, with an ex-house, right? Aspects and testing things out, but have at least a few who is my sponsor, who brings me then to the next have at least somebody from IT involved to say like, hey, we're testing this out, not sure if it works. It may not work out, but it will go wrong, right? But you have a concept, a sense of when to move further, to be frankly fair. If you're not starting that, if you're starting, oh, now we invested 3 months, 6 months in the POC, nobody knew about that, no sponsor, no IT involved or someone who can operationalize that. That's the death kiss of your POC, even so it may be a cool aspect in there. And that's why I think this kind of communication needs to go in there, right? And the same goes then for operations, right? Knowledge sharing strategy, not only OT, but AI, and it's these kinds of community. Make teach-ins, what we call that, right? Give them 40 minutes, hey, this is a bit of the state of the art, what's going on, to get them on the road, get them part of your journey aspects in there. In scaling, I'm sorry, this is a bit of a busy slide, right? In scaling, we came up with, like, okay, consulting kung fu, so you have 5 steps to heaven, right? So we came a bit of an aspect to like, okay, how do we overcome this pilot trap? And we gave it now a bit of 5 nice names in our factories, right? It means like cautious explorer, right? I get started, I have a local disconnected, maybe isolated notebook environments. Everybody knows that. The working student tested it out, or somebody, a cool tech champ in the organization kept it out. The pilot pioneer, that means, yeah, pilot after pilot after pilot. Then the committed scaler, I want to have a process actually implemented in this. Then the global multiplier, I say like, okay, I'm applying it to the second factories, let's say, and then the AI ops front runner, right? And most of the aspects stuck actually in the 80%. A lot of aspects stuck in this pilot pigottery, what's sometimes called. I mean, it's a bit of the pilot trap. And that was between level 2 and level 3 is mostly the aspects where everybody's struggling the most. What we then started is like, okay, actually there's a couple of frameworks, right, for doing, assessing your AMR maturity and stuff like that. We thought it could be interesting to have something which is more, let's say, industrial AI grade, and say like, what is scalable in the industrial environment? What is reliable in the industrial environment? What is security in the industrial environment? So this is one part of a bit of a radar, which is 20 dimensions, but in terms of, okay, actually, give me the best practices along the line, how do we mature these kinds of things more specifically, right? And based on that, you can then, and this is just exemplified now, and you can say, okay, you know what, if I'm level 2 now in my scaling aspects, I want to go level 3, become, part of the pilot, let's say, trap, right? What things do I need to do, right? What aspects, actions, activities I do to go on further. And I think it helps sometimes to have this a bit of more structured view to say, like, okay, with regard to security, with regard to reliability, with regard to scalability, with regard to MLOps pipeline, with regard to training, with regard to, these kinds of gravitas helps certainly, right? And so happy to discuss more. If you slice a bit down, then you can, if you talk on a techie level, then you may talk about 4 different aspects in scaling. One aspect where we look more specifically is the model scaling. So how robust is the model in scaling to other environments? Mostly people train a certain kind of system, it's trained on this kinds of data and never scale to others because it doesn't have this generalization aspect in there. It's a one-trick pony, which sometimes is good, because if the business case is here, then it's a cool thing, but it's a one-trick pony, right? And how do you make this one-trick pony a multi-trick pony, let's say? This is the model aspects. The second one is about customers. How many clients is adjusting? In ad industry, that's a very good thing. It scales over customer, right? It's not the environment, it's actually scales over customer. So also in mind, maybe in your factories or in the shop floors or in your partners, right? Who else needs this capability as well? Maybe it's a one-trick pony in your factory, maybe in your community, but maybe it's a multi-pony, let's say, across customers and other customers in there. Third one is life cycle, and I think if you ask now modeling, yeah, can you update the model, and then 10 people need to tackle 20 software artifacts and need to talk to IT, and they make a ticket, and then OT, they make another ticket, and the ticket is even not synchronized, so you lose a lot of time in there. And there's how much of your life cycle in the MLOps aspect, AT to OT, is actually automated. And there are certain kinds of pieces you need to do, maybe sometimes stick together. Everything fully automated is sometimes almost not doable, to be frankly fair. But you can need to increase the automation on the life cycle of the application. And then the application itself, and everybody felt it already with regards to GenAI. The one is doing, I don't know, recommendation of latest trips or maybe good restaurants if Hannover is busy, right, on a fair, stuff like that, right? So these kinds of multi-applications aspects we see in industry arising with regards to vision, with regards to language, with regards to operation, with regards to engineering. These kinds of multi-applications is quite an interesting aspect. Therefore, for each of the individual aspects, actually, good thing. Generalization, think about robustness, reusable assets are actually quite nice, always tricky. If you are in a corporate and everybody will say like, hey, what is a reusable, what is a blueprint, what is an, use inner source, code source, like GitHub, these kinds of technical artifacts, but also reusable as, which you can say as a playbook maybe, as a prototype, as a blueprint. These kinds of aspects are very essential in a production and manufacturing department. Because if you went the journey for 10K running and learning your best practices and making all the failures in the world, which is okay, at least, shape that to the other factories, to the other lines, to the colleagues. And how do you package this kinds of best practices is quite an aspect. Standardization is still a mess. If you go to a shop floor, if you go to manufacturing, you have, 40 machines. Everybody speaks different protocols. Maybe some OPC-UA, maybe some not OPC-UA, maybe some PAC-ML, maybe some Weihenstephan, maybe some, certain kinds of standards, but it's still quite a mess. And therefore, I think, being your chief data officer by yourself and say like, okay, let's talk about what is the common standards, plant data model, these kinds of, with every POC and with every prototype, with every initiative, you should enhance the standardization of your organization. You should enhance the data standardization of your organization. All right, 8 minutes to go. Let's give me another 2 or 3 minutes to look about aspects. You've been very, very calm in terms of staying here with me for an hour. I know it's a pain. So what's next, industrial AI? And you can sense it already. I think there's a cool stats. IoT Analytics actually cool dudes. Actually, I met them also yesterday here. They're wandering around. They analyze the earning calls of the CEOs on a regular basis, and that's actually a cool thing. So if you ask what are the CEOs talking about, right, that's actually always a cool stat, because in the earning calls everybody does the buzzword bingo, but also somehow they get requests for this and asked what does it mean in your organization. So it's a mixture between too buzzy, but still there needs to be some fundament behind it, right, in these earning calls. So, and that's why I think it's a good pulse check if you want to, what's the next strengths. And obviously after Davos, this is the numbers on Q4 24. So Davos was arising, so everybody talked about agentics, right? So in terms of, building AI agents, as you can see maybe also here in the Hannover Fair already as a bit pulse check, right? And so what does agentic actually mean? And I think I love this from capital actually aspects. I extended it slightly. But they were asked about what is a disruption, right? And how to detangle disruption of Gen AI. And I think one could slice it. So what is a disruption? A disruption is when a new platform arises on the data side, data disruption, right? Is a new platform comes, and with new platform comes, the capabilities, the cost, the margin cost comes significantly down. This is the disruptive element that you have in these kinds of aspects. And in terms of data, we had this previously. That means on the one side was data distribution. Internet came, very costly, very limited. And then comes scale. Now I can spam you all, billions of people I can spam at a very low cost, right? So disrupted, the margin cost went not to zero, but it's significantly down. So one can say internet was in terms of data distribution a disruption. The second aspect was storage. So we had the internet now we came to aspects, okay, Dropbox, right, S3 buckets, and these kinds of business models attached to that. At the beginning, right, storage cost high. Now, it's not zero. I know the cloud cost of Siemens, right? It's definitely not zero. But, the margin cost of these kinds of services is significantly down, right? And the business models are along there. We are currently at the third level on the hype level. That means the generation of data. And we still haven't detangled it. Actually, we still haven't detangled it about the generation of data along the line, which is, not only generating ads and aspects, but other, right, synthetic data, recommendation data, right? And I think we're still on the hype on learning how do we entangle that and how do we get the cost down, and to be frankly fair, right, in these kinds of aspects. We're still at the media stage, right? It's not zero. Data generation is not zero, right? Model still goes up. We still need some competitive edge. We need still have some open and closed source aspects in order to get the business model down there, but the cost will go down, and therefore it will be and is, for me, according to this definition, a disruption. And the next or upcoming thing is agentics. And agentics in this kind is a bit of Gen AI and automation on steroids, if you put it in this kinds of aspects. And what it will do is it will bring down the data intelligence. Intelligence is a strong word in AI. As an AI geek, to be frankly fair, so I don't want to go in this kinds of philosophical discussion now what intelligence is. But this automation, it will go in terms of data intelligence, the cost will go significantly down. Maybe in 3 years, maybe in 4 years, maybe in 5 years, but around this scale, to be frankly fair. It will totally rethink what we now call in corporates RPAs, corporate gaffer tapes. You know, there's no API, some human need to press. All right, let's throw an RPA agent on that, right? So Gen AI and automation will join together to agentics in having highly automated workflows. This will be big. This will be big in IT systems, very specific, and also in terms of knowledge management aspects there. And you can sense it a bit of an aspect, right? Typically, as you do it, if you're now doing your, travel reimbursement because you come from Hannover Fair and so like your corporate should pay for it. So usually you uploaded it, your PDF document, then there's some magic, or some kinds of application which extracts maybe the billings or the hotel name or whatever you're reimbursing here. And then you store it representative in there, right? And so in an agentic workflow, it's more, okay, it tries to extract, it has some computer vision, it maybe aligns it with the SAP records already, it comes then to, okay, this was breakfast, this was hotel, maybe it checks, oh, you have actually not the right of reimbursing a €300 hotel room, so it comes, different capabilities are packaged and orchestrates then as a workflow environment. So you enhance your typically one-to-N application in terms one-to-N to M application. So not only human-computer interaction, but human-computer to software capabilities, workflow orchestration together. Previous last slide. Then we have obviously this Gen AI spending. You see it everywhere now, Gen AI in software, right? And so the big question is this now a new business, right? Can I sell it? How much is a Gen AI feature, a Copilot, industrial capability, right? Actually worth, right? And we will see that it's actually a feature. You can compare it if you buy an Airbus and I innovate you a new cool seat, which is now green, super nice design, and I will charge you $1,000 for it. Then you say like, I paid 50 million for the Airbus, and you want to charge me $1,000 for the green seat? Seriously? Similar kind of discussions you will have. Everybody's expecting to have Gen AI features in your software. And if you're not having these kinds of features, capabilities in your software, you're out of the game anyway. You may be not participating in the market as well. So that kind of trend will come. And last but not least, obviously, this goes also, and you may experience a little of PR now of Siemens, at least the last thing, PR of Siemens, bear with me. So that means agentics, you can sense a couple of such agentic, let's say, workflows capability already in our industrial copilots. This is actually Bianca doing that. That means we package certain kinds of things of an app store, certain kinds of agents in terms of the industrial copilots as a workbench, where it's like, okay, it can web scrape, it can read documentation, it can read engineering information, and we orchestrate these kinds of things together. So this kinds of workflows orchestration becomes now also a part of our software suites. So it's again, it will be part of the feature, right? Maybe with certain managed service on top of it, but it will be part of the feature. And with that, 1 minute. To go. Thanks so much. Happy to have maybe a single question or raise on the Q&A. Other than that, I'm delightful that you all stayed. Almost everyone stayed here in this noisy environment, and I hope I added some value for your morning day, for the coffee, or for your tour that you do around. So thanks so much. All right. Thanks so much, then.